Evening all, and welcome back to Factorio. I'm not joined by NOG again. This is the last episode we'll record separately, and then get back to it on the weekend and record things together again. But I have been looking around at trying to figure out what is wrong. I've just noticed there's a capital H in my name at the end there. Wow, we've been playing this game for so long. I've been looking at what's what and what we need and where we need it, and we are struggling like mad for wire. If I come down here to our red circuit, we have no wire being made, and the wire's not being made because all the wire is being used up here that we're making on the train system to go to the green circuits. But these green circuits are not enough, nowhere near enough. I know we've got a second set, but we have, my mouse over this here, 96 machines making green circuit. Okay. We need 162.1 if we put speed modules in them, but we can't put speed modules in them because the belts give up with the line here. If you don't put any speed modules in them, you can deal with 6 on a line, which is what we got here. 6 on a line maximum, and then this belt becomes saturated, and it goes off there. And conveniently, if you then build assembly machine 3s that make wire and put a single speed module 3 in them, they work at exactly the same pace. So you could have 6 machines making the wire and 6 machines using the wire, which is kind of what I want to go for. I kind of want to build that and change our green circuit up. I know we got some here, and then trains, double train. Then not built some here, but it's not right now. It's sat there not doing a great deal, because the stuff that uses it just isn't getting the wire in. So we need more wire. So I'm thinking of rebuilding the green circuit system so that it doesn't require this. It just takes copper and iron and produces them. So we produce the wire on site. I know that's not how we were doing it. We were going to have individual outposts, but the amount of copper wire you need, trains just are not going to cut it. They are just simply not going to cut it. So that's what I'm thinking of doing. I'm thinking of changing this all up here, and then we'll take this out and we'll take this one out afterwards. And I'll take this one out first, and I think I'll build up here, and we'll build our green circuit production right up here, and get everything working. And then once we built the green circuit production, we can come down maybe here, maybe somewhere, who knows, and build some wire for our red circuit. Because if we were to say, right, we need, we're not putting speed modules in them because, again, we're limited by the distance you can travel on one there. So we need 13,366.667 or 66 reoccurring red circuits. So I'm just using the calculator here to calculate what I'm doing. So if we say yeah, that many. Boom. Oh no, that's factories. No. Items. We don't want 13,000 factories. Wow. That's 1,069.4. So 1,070. We'll go with 1,070 red circuit machine. Boom. There we go. If we don't put speed modules on them, that is only 5 belts worth. But what comes down is the copper wire. The copper wire that's coming in here. This is the copper wire coming in here. A single belt can only supply so many of these machines because you just run into throughput issues and you get problems with it. And I think that number is, I mean, if we put speed modules in them, we then have issues with copper coming in as well, which causes problems. But let me see. So it's 1,070 factories. Let's have a look here. So if I go, how many have we got in a line here? Because this, I feel like I figured this out already. We've got 36 in the line. So if I go 36 factory, that is 1.7 belts worth of copper cable. So this won't work. This will never work. this cannot get enough copper cable in to feed all these machines. So the red circuit build won't ever work. Yeah, 36. 20. It's 21. It's 21 machines. Yeah, we can get a maximum of 21 machines on a single line before the belt falls apart. So that means this is never going to work. This build here is never going to work. Because I didn't think about the throughput when I designed it. I just looked at the numbers and didn't think about it. But the good news is, if we were to say, let's do 20. 20 is a nice number, okay? And we need 1,070. Doing lots of maths here, sorry. 1,070 divided by 20. That means we need 53.5 lines. Wow. Wow, 53 lines at 20 long. That's way more space than we have here. There's enough to do it here, but we couldn't get the copper in. Yeah, there's not enough space to modify this as well for it to work. So we're going to have to rebuild the red circuits as well. Yeah. Yep. Yep, we're going to have to rebuild the red circuits. Oh dear. Oh dear. It's only going to be 20 long. And then 54 rows. So 54 times 20 is 1,080. So that's more than we need. But that's nice round numbers. So yeah, so this is going to have to be redesigned as well. Oh dear, I hadn't thought of that. All because of the input. And I suppose if I'm going to redesign it, because we're going to have to redesign it. I might do the same thing. I might just bring copper in instead. So we bring copper, plastic, and green circuits in, and make the copper in situ. Because the copper, one copper becomes a single. One copper becomes one wire. No, one copper becomes 2 wire. Sorry. So it makes sense to bring the copper in because then you're doubling the throughput. So we'll do that. But I need to look at this here. This is all slowing down. This is all not working properly because we don't have enough copper wire going anywhere, doing the things we need to do. So we need to do this. And I have designed something. Again, looking at the throughput, which I didn't do before. If I come up here, this is ironically all working and all backed up because of But this here is the highest throughput you can possibly get. I need to nope. Okay, so I need to put 1 in each. Oh. Grab those and grab those. Thank you. There we go. Okay, so this works. So what we'd have here, we'd have copper coming on this line and this line, steel or iron plate, coming on this line and this line. If they then go in, the iron goes over to here, the copper goes to here, the copper goes to the central line. This central line will be completely saturated. So these can fill one of these belts. These can do the 2,700 a minute. So it will completely fill this belt. And these will use it all because these use 2,700 per minute, 6 of them with no speed modules in. And then they can output onto this outside line. I've got 2 long iron inserters because they're slow. I'm kind of hoping that's going to be enough to output. If not, we'll have to figure something else out. The problem with these is that they are quick. They take 0.5 of a second to craft. I don't need as much iron plate in. So I think that will deal with it fine. We might have to upgrade these to be faster. These are half a second as well. These rotate at 864 a second, which is more than twice a second, which is good. That's what we need. We need to rotate more than twice a second in order for it to fill that up in time. So I think this would work. This throughput will work here. The problem with this is that we need, if I remove that there, 486.2, and each single row is going to have 6. 486 divided by 6 is 81, so we need 82 rows. Yeah, we need 82 of these somewhere. Now they are fairly short, which is lucky. So we don't have to do like all of them in one go. We could do, if I wanted to put it here, we could do some there, but I don't know how large this area is. I don't know whether I could have the trains come up and drop off. We need a lot of trains dropping stuff off as well. Because, well, actually, I don't think we do need a lot of trains drop off. Hold on, let's have a look, see here. So this uses half a belt of copper. So if you're doing 82, that means we need 82 belts of copper coming in. Because we need 486 of them. Wow. Uh, 486 divided by 6. Sorry, it was that's right. 486 divided by 6 was 81, but it's 6.2, isn't it? Yeah, yeah. So it's going to be 6 times 82. So that, yeah, so that means we need 82 lines of copper plate, because it uses half a line. So one line can be split between these two, which is fine. But wow. And my build up here. This is 32 lines. We need three of these. 1, 2, 3. Less than 3 of these, but yeah. 2.5. Need 2.5 of them. So I'm gonna have to split it up into segments, because there's no way we can have that. I couldn't build a whatever an 82 to 164 splitter or balancer, because no. No. So we might do this. We might just copy this. We've got 16 lines. 4, 8, 12, 16. I know we don't need 2. Sorry, I've divided that by the wrong number. 82 divided by 16, because it's 16 lines. So we need 5 of these. 5 double stops. 5.125 double stops. So that means it's 5 and a little bit. That's really annoying. Jesus, 5 of those. We come up here and we did 5 of them. I'm thinking of come up here and having all the train stops this side, and then it goes across the double rails, and then we build things over this side here. I think that's kind of the way to go. Then our electric engines are completely individual, and they'll be fine doing their own thing. We can take this down, do things here. Jeez Louise. Yeah, I think this is the best way to go. This is the best way to go about it, is to break it down. We'll break it down into five of them doesn't. I can't do 5. It's got to be 6. So 6 times 16 means we're going to make 96. We're going to be making more green circuits than we actually technically need, but it's going to work better for us in the long run because of ratios and things. So it's just easier to build if I build one. If I build one based on 16 lines, and then figure out the iron and all that sort of things, and then I can just go, hey, copy this 6 times. That makes sense, and then have the outputs come out, and we'd have or however many outputs we have come out go into station, and we'll figure that one out. So that's the idea, that's the plan, that's the goal, and I am once again not going to do a lot of it on camera because, well, what I'm going to do right now is we're going to come over here and I'm going to turn off all of this running. So stop getting iron plate, and let it just burn off what it's got in here, because it's really awkward picking all the stuff up. Even with the robots and things, it's really, really slow. So yeah, I think I will stop all the iron plate coming in there, which is easy enough done. I can just literally change the train signals to 0. So no trains ever come up here. But I'm going to wait for this to empty and then tear it down and then rebuild it in the same location. And we could go over here and I could build it out here and duplicate it and then tear this down afterwards. Maybe that's better. Maybe that's better. Although we do have oil and stuff out here. I don't really want to go over the oil. Yeah, I don't want to go over that oil. I'm not fussed about all this up here. This is all clear up here. Maybe we should come up and just start just above the oil, and it's a little bit away from the line. Yeah, let's do that. Let's do that. Let's build it somewhere else. Let's not tear. I've turned these all off, so they will eventually run dry. It uses way more copper than it does the other stuff. So we'll see how it goes. So can I get a 4-lane straight? No, that's the old 4-lane straight. We're not doing them anymore. That's a stupid long one. I don't want. I need to build a better 4-lane straight and then copy it. Because I've. Oh, and what I also need to do as well. Go and get some cliff explosives. I don't have any, and we're going to run into some. Can I call a train? Don't we have a cliff explosive train? Hey, Cliff, there you are. Yes, but we don't have many in there because we're not making any. So many things I've stopped working over time, and then now I regret doing it. We still got artillery cannons here. No, we've got laser defense. This isn't needed anymore. Right, can I... Oh, do you know what? Take that back. Take that back. We are going to, first and foremost, come down here, grab this. Oh, should have stayed in Spidertron. Much safer. 2, 4, 6. That'll do. And we're actually going to run away. We're going to tell Spidertron to come down here. I'm going to press tab to go over to my flamethrower. And we're going to convince some of these trees to go away. And I'm going to let it burn. Shoo, trees, shoo, you're in the way. And we'll let that burn for a while. We'll let it burn. And we'll come back when it's burnt a bit. Okay, so there's the last of the trees gone. Let's grab some more of these because I ran out halfway through, and we have a lovely clear area, which has all been chopped down. Most of it's been burnt out and then chopped down by the robots. So, oh, I missed some more down here as well. Oh, wow. So, those, and got some gifts here as well. Kaboom! Yay! There we go. So we have a nice area cleared out around here. I don't know if anything's still on fire. I think it may be. No, this looks cleared out. This is quite thin trees here. Maybe the robots grabbed everything going on there. I think I lost some robots as well. No, 43, still on 43. We're okay. Nukes. So yeah, so we're gonna build the thing in here, but I'm not gonna build it now because unfortunately time has got the better of me, and I need to go and actually do the real life thing, which is really awkward. But oh well, that's just the way things go. So we will actually leave this one here, and then next episode when I come back, which will be playing with Nog, we can I will build the new circuit system up here, and we can get going. What I should probably do is copy this, paste it down here somewhere, so at least semi remember what I was doing. There we go. Awesome. It's not going to stay there. Obviously, it will go further up here, but I just want to paste it down there so I remember what I'm doing. These are all going to be completely full of things here. This has all come to a stop. I've removed all the stations, so it's actually come to a halt now, which means that these are just running our advanced circuits. I need to do something about the stuff that's in the boxes, but I might just run some lines over to here, just to add it to this system, and drop it off in here. So, but it's fine. It's fine. We've got opportunities. But we will leave it here. We shall come back next time. Thank you very much for watching. I hope you have enjoyed this one, and I hope to see you again in the next one. Until then, as always, have fun.